Oh. Oof. Fall backwards. All right. So we're going to go through some percentage problems. We got some brain exercises down at the bottom on page 5 to do. We're not going to do all the brain exercises. We're just going to do a few of them because the pattern on all of them is the same. Couple things to remember about percentage problems. First of all, the word of means to multiply in math lingo. So when you see like 60% of a number, that means to multiply the number by 60%. So that's kind of important. The other thing is you cannot simply add and subtract percent changes. So in other words, if you see something that goes up by 5% and then it goes up by 10%, it did not just go up by 15%. You can't just add those numbers together. It doesn't work that way. Okay? So don't do it. All right, so a little bit of math exercise down at the bottom, brain exercises. To convert a decimal to a percent, you multiply by 100. So if we look at number 1, 0.46 equals what percent? Multiply by 100, guys. Move the decimal 2 places over. So it's 46. It's just 46%. Okay. All right, I'm not doing 2 and 3. We're going to do 4. To convert a percent to a decimal, so we're going backwards. So instead of multiplying by 100, we're going to divide by 100. So 63% is equivalent to what decimal? 0.63. Let's move the other direction. All right, next page. Number 7 at the top. These get a little trickier. To convert from a percent to a fraction, take the percent value, throw it over 100, and then reduce. So number 7, you have 55%. So all you're going to do here is take the 55, throw it over 100, and then reduce down. 5 goes into both of them, so 55 divided by 5 is 11. 100 divided by 5 is 20, so this is equivalent to 11 over 20. And you're done. You've just converted a percent to a fraction. Okay, don't make that difficult. All right, again, I'm skipping 8 and 9. Let's go to 10. To convert from a fraction to a percent, you want to change the fraction into a decimal first by dividing the top number by the bottom number. And usually you're going to be able to do that in your calculator. So number 10, you got 3/8. So take 3 divided by 8 in your calculator. So if you take 3 and divide it by 8, you're going to wind up with 0.375. And then just convert that to a percentage by multiplying by 100 or just moving that decimal 2 spots, which is 37.5%. Done. Okay. 11 and 12 are done the same way. Yeah, I can do one more of those. All right, number 11. Number 11, you got 1 over 125. So take your top number divided by the bottom in your calculator. You should get 0.008. Now multiply by 100 or move your decimal 2 spots. Ba-dum-ba-dum. So this is 0.8%. Okay. Better? Yeah. It's all good, man. I actually have seniors in AP Calculus who cannot do this. So I don't know. It gets lost somewhere along the way. So we fix it. That's my job, is to fix things. Don't be afraid of things that are under 1% or over 100%. Okay, it's going to happen on these tests. They like to do that to you because it kind of screws with your brain. So don't be afraid of it. Okay. Also, never be afraid to admit that you don't know how to do something. Believe me, I've seen it all. Okay. And my job is just to fix it. And that's what I do. All right, ACT number 2. This is a basic problem. When 15% of 40 is added to 5% of 260, your resulting number is what? So again, that word of simply means to multiply. That's all it is. Okay. So 15% of 40. 15% as a decimal is 0.15. Of means to multiply. So we're going to multiply that by 40. Is added to. Apparently I'm adding. 5% of 260. So 5% as a decimal would be 0.05. Again, move that decimal 2 spots. of 260. So I'm multiplying by 260. Throw that mess through your calculator, and it should spit out 19. So if it spits out 19, your answer is A. Okay, again, real basic problem. Number 7, a little bit harder. If 40% of a given number is 8, then what is 15% of the given number? So let's translate this. 40%. 40% of a decimal is 0.4, or 0.40, same thing. Of a given number. Of means to multiply. A given number is something I don't know. So I'm going to multiply by something I don't know. X is, that means equals, 8. Ooh, that's an equation. I can solve that. I can solve that for x and find my given number. Divide both sides by 0.4. That should give you 20. So my given number, my mystery number, apparently is 20. So let's see if we can answer the rest of the problem. Then what is 15% of the given number? So I need to find 15% of my given number of 20. So 15% is a decimal, 0.15. Of means to multiply. My given number was 20, so 15% of 20, I believe, is 3. And that would be my answer. It would be 3, which is C. Okay. Questions on that one? All right. SAT number 38. This one falls in that special problem category. The number y is 20% greater than the number x. The number z is 20% less than y. The number z is how many times x? Do you see the difference between the ACT problems and the SAT problems? Okay. So, the number, let's just translate it. The number y is, means equals, 20% greater than the number x. Okay, all right, we can do this. 20% greater than x. So that means I'm going to take x. If it's bigger than x, I'm going to be adding. And I'm adding 20% of x. All right, 20% of x. So I'm taking whatever my original number is, and I'm adding 20% back to it. Okay? All right, we can simplify that. This is like 1x plus 0.2x. That is 1.2x. Check. Got it. Good. All right, let's go to the second equation. Ma'am. This is like 1x. So 1 plus 0.2. Yep. No worries. I get that question a lot. All right, next one is the number z is, so z equals 20% less than y. So I'm going to do the same thing I did here, but this time I'm doing 20% less than, so I'm going to subtract. So I'm starting off with my y, and I'm taking off 20% of y. So this is 1 minus 0.2, that's 0.8. Squeaky marker. All right. And they want to know z, what is it? Z is how many times x? Well, this is kind of as far as I can get. And they're just asking me to compare z and x. They're not giving me a starting value. So that means I can kind of make one up. So I'm going to make up a starting value. And I can kind of pick any letter I want to start with. Well, I'm going to start with x, and then I can calculate y, and then I can put y in there and get z. To me, that looks like the most logical progression. But really, I could start anywhere. It's just going to make it more complicated if you start somewhere else. So I'm going to start with x. Pick a value for x. Doesn't matter what it is. 2 sounds good to me. I like little numbers. All right, if x is 2, this is going to be 1.2 times 2, and that's going to give me y. So 1.2 times 2 is 2.4. All right, so y is 2.4. So if y is 2.4, plug that in here. 0.8 times 2.4 is not something I can do mentally. Is 1.92. So I've got z, I've got x. They want to know how many times z is of x. So I'm going to take z and divide it by x. So z over x is 1.92 over 2. and that's 0.96. And that's how you would have to grid it in. As a fraction, that's 24 over 25. You'd be a box short.
So are the numbers 1.2 and 8 the same thing as 1.2 being 120% of x and 80% of y?
Yes, ma'am. Yep, same idea. Okay, now that's the right music. Okay. Any questions on this one? All right, so SAT gives difficulty ratings to their problems of 1 dot, 2 dots, and 3 dots. It's the dumbest difficulty rating I think I've ever seen. This is a 3-dot problem. So that's kind of a doozy. All right, next page. Oh, itchy. Okay, up at the top, you've got 13 and 14 are ACT questions. Try those guys on your own. They're not that hard. Of course, you guys know if you have trouble with it, there's always Thursday's help session, and you can always ask me about them in class. Let's do SAT 17, which is partway down your page. A number increased by 25% and then decreased by 20%. The result is what percent of your original number? Again, all they're doing is giving you percent changes. They're not telling you a starting value. So let's pick one. What number do you want to start with? 2. Let's start with 2 again. That works. I like little numbers. Okay, so we're starting with 2. And it says the number is increased by 25%. So we're going up by 25%. So again, I'm going to start with my original number. If I'm increasing, I got to add 0.25 times my original number 2. So what is 2 plus 0.25 times 2 is 2.5. Okay, so now I'm at 2.5. Now, once I'm at 2.5, it says that the number is decreased by 20%. So I got to come down 20%. So 2.5 minus 20% times where I'm at, 2.5. Where am I at now? Now I'm back to 2. Well, shoot, I'm back to where I started. So my result, 2, is what percent of my original number? 2. 100. I'm 100% of my number. I'm back where I started. So that's answer choice B. I'm assigning you the bottom one for homework. You should be able to do that in 2 seconds with no calculations. Anybody tell me why you can do that in 2 seconds with no calculations? It's the same damn problem. Okay. The reason I put the same problem on here twice is to show you. I have a lot of people that tell me you can't possibly study for both tests at the same time. They're too different. Here is the exact same problem that's on both tests within the last 2 years.
So if you were to do it without substituting a number, if a number is increased by 25%, wouldn't it be 1.25 and then you take away 20, but then you're left with 1.05?
But you're not taking away. See, that's where this gets tricky because you're not taking away with 0.2%. You're not taking away 0.2x because your x has just changed. Your original number has changed. This 2 is no longer 2. This 2 becomes 2.5. This end result changes. So you can't simply subtract off 0.2. That's why you don't want to do these problems with letters. Do them with numbers. It will mess you up every time. Okay. Next page. Top one is yours. Second one is yours. Third one is yours. Well, shoot, that whole page is yours. Now that I'm looking at that. Okay. So flip page 9. Okay. All right, top of page 9, we got ACT number 1. At a restaurant, diners enjoyed an early bird discount of 10% off their bill. If a diner orders a meal regularly priced at $18 and leaves a tip of 15% of the discounted meal, no tax, how much does he pay in total? So you have 2 things going on. You got a discount of 10%, you got a tip of 15%. The order in which you apply these is important. According to the problem, what order do you have to apply this in? Which one comes first? The 10% off has to come first. Life lesson, when you're tipping somebody in a restaurant, you tip on the full price of the meal, not the discount price. Okay. So, we're taking $18, we're discounting it by 10%. So 18, subtract 10%. 18 minus 0.10 times 18. Throw that through your calculator, you should get $16.20. We are now at $16.20, and this Yahoo is adding 15% on that instead of on the original 18. So this plus 0.15 times 1620. If we do that, we should get $18.63. I got a little dyslexic there. There we go. Okay, any questions? Ma'am?
Why do you do the plus 16 at that time?
Right here?
Yeah.
You're taking your original amount and you're adding 15% to it. If I only did the 15%, I would just have the 15% amount. I wouldn't have it adding back. Does that make sense?
Yes.
Okay. You can also do 1.15 times 1620 if that helps. Get you the same place. Okay. SAT number 17. Michael performed an experiment where he tossed 2 coins, 1 dime and 1 nickel, at the same time, and recorded whether each one landed on heads or tails. His results are shown in the table below. For what percent of the tosses did the dime Michael toss land on heads? So we want the percent that landed on heads. Okay, so this is a part over whole problem. So if I want the percent that landed on heads, I need the number of times it landed on heads divided by the total number of coin tosses. And again, I'm only worrying about dimes. So I want dimes on heads divided by the total number of coin tosses. So this chart's a little funky. This is called a two-way table. Can anybody tell me the number of times the dime landed on heads? Ma'am. And there's one more. 27 is part of it. But where else did the dime land on head besides the 27? And this is usually where people get stuck. I don't care what the nickel's doing. Where else did your dime land on heads? 26. Yeah, the 27 and the 26 is where the dime landed on heads. So the 27 is where both coins landed on heads. The 26 is where your dime landed on heads and your nickels landed on tails. Again, I don't care what the nickel's doing. I just want the dime to land on heads. And then on the bottom, you're going to add everything up. So 27, 26 plus 24 and 23. You get your total. Okay. And that's going to be 53 out of 100. So that's going to be 53%. Any questions on where those numbers came from? A lot of people have issues with this table. Okay. All right, we have the percent change formula. Let's talk about this formula. This percent change formula should look somewhat familiar for you if you've taken chemistry. It should look like percent error. Now, percent change, they don't have to just ask you for percent change. They could ask you for the percent increase, the percent decrease, or the percent discount. But any of those words mean to use this formula. So percent increase, percent decrease, percent discount, they all mean to use the percent change formula. Okay, and the version of the percent change formula we're going to use is the one on the end that says new minus old over old. That's the one we're going to use. All right, so let's look at a basic problem first. ACT question. Dimitri, our buddy Dimitri bought a pair of pants at a discounted price of $30. Good job, Dimitri. The original price of the pants was $40. What was the percent of the discount? So again, percent of discount means to use our percent change formula. So it's new minus old over old times 100. So my new price was 30. My old price was 40. So new minus old over old. And then I just multiply by 100 to make it a percent. So if you want to do the conversion in your head, that's fine. 30 minus 40 is negative 10. So that's going to come out to be negative 25%. So my answer is just 25%. I don't care about this negative. That just tells me that it went down. That means it's either a percent decrease or a percent discount. So I don't care about the negative. It's just 25%. questions on that? Okay. SAT question 8 at the bottom is yours for homework. And we're moving on to mean, median, and modes. M&Ms. Okay, quickie review. Your arithmetic mean. Your arithmetic mean is the same thing as an average. So all you're doing is adding everything up and dividing it by the number that you have. That's your mean. Your median. Your median is like your median in your road. It's in the middle. It's your middle number. The way that people screw up median is they forget to put things in order from least to greatest. So make sure you order your numbers from least to greatest first before you find the median. Mode. Your mode is the one that occurs the most often. It's pretty much the easiest one to find. We're going to add to that the word range. Your range is simply your highest value minus your lowest value. Easy to find. Okay. All right. So we have normal average problems and we have funky average problems. Okay. For our normal average problems, our normal average formula is fine. Average equals our total divided by the number of things we have. That's our normal average problem, or a normal average formula. When we get to the funky ones, this is not particularly helpful. So we're going to do a little algebra. We're going to multiply both sides by n to make our n's cancel out. And I'm going to wind up with a times n equals t. Average times number equals total. When we get to the funky average problems, this is going to be much more helpful to me than my original one. Okay? But I wanted to show you where it came from, so you don't think that I'm just pulling formulas out of thin air. All right, so that's going to be helpful later. Little tip in big bold letters: never, never, never average more than one average. Okay, so if you're given multiple averages in a problem, you never average them together. You never add them, subtract them, multiply them, or divide them. If you find yourself doing any mathematical operation with more than one average, just stop and go to plan B because you're wrong. Okay? All right. Brain exercise down at the bottom. Number 1, based on the table to the right, what is the mean hourly wage for the 11 workers? How am I going to find it? What am I going to do? Right, but be careful. How many 9s do you really have? Yeah, you have 2 9s, you have 2 10s, 1 12, 2 13s, and 4 14s. Make sure you account for the fact that this is a frequency table. So they're telling you how many of each number you have. So just be careful when you do that. Okay, so run that calculation real quick. 2 9s, 2 10s, 12, 13 times 2, and 14 times 4. Get yourself a total. And you have 11 workers, so you're dividing by 11. Yep, your average should be 12. So for number 1 on your brain exercises, your average or your mean should be 12. When you go to do your median, same idea. Make sure you list out 2 9s, 2 10s, 1 12, 2 13s, and 4 14s. And then find your middle number and just hack in from the ends. Yep, it should be 13. Should be your middle number. Okay. And then your mode is just the one that occurs the most often. So the one that occurs the most often should just be 14. That's kind of obvious from the table. Okay. Your whole next page is homework. They're similar to what we just did. And then we're going to go to the top of page 12. So number 7 at the top. To determine a student's overall test score for the semester, Ms. Lopez throws out the lowest test score. That's nice of her. And takes the average of the remaining test scores. Victor earned the following test scores. Ms. Lopez class this semester: 62, 78, 83, 84, 93. What overall test score is Victor going to earn? So what number are we throwing out? Throw out 62, take the average of the rest. What do you come up with? Add them up, divide by 4, what do you get? 84 and a half. Yep, should be E. Okay. SAT number 33. This is a grid in. The mean of the 5 numbers below is 1600. What is the value of X? Okay. So our normal routine for finding the mean or the average is that it's the total over the number of things that we have, right? So let's plug in what we know. We know the mean is 1600. Our total is going to be those numbers added up. So 700 plus 1200, 1600 and 2000. Plus the one we don't know, X, over 1, 2, 3, 4, 5. And we only have one letter, we can solve that for X. So that's 1600 equals, let's simplify that top there. So 7, 12, 28, 30, I think that's 3700. Did I do that right? No, 5500. Okay, apparently I can't add. 5500 plus X over 5. So I'm glad I haven't worked out ahead of time. Okay. And then we're just going to solve for X. So multiply by 5. So 1600 times 5 is what, 8,000? Yeah. 8,000 equals 5,500 plus X. Subtract your 5,500, that's 2,500. So X is 2,500. Okay. All right. I've had students look at this problem before and go, oh, X has to be bigger than 2,000 because of the order they put the numbers in. Not true. Your SAT will do this to you and put X at the end of a list of numbers like that, and then X will be like 100. So do not rely on the fact that the orders are numbered to mean that X has to be bigger than 2,000. It was in this case, but it won't always be. So don't fall in that trap. All right, SAT number 6. Lionel purchases 1 pound bag of each of the 5 seeds and nuts shown on the table. Of the following, which best approximates the average or arithmetic mean number of calories per bag? 1 pound equals 16 ounces. Why is the word pound underlined, and why are they telling you that 1 pound is 16 ounces? Sir? Right, your table is in ounces. Your table is 1 ounce servings. Good. So that means we're going to have to convert. So every single number in this table is only for 1 ounce. He's buying 1 pound bags. So he's going to have to buy 16 of these 1 ounce bags in order to make a pound. Does that make sense? So you have a choice. We know to calculate the average, you got to do the total divided by the number. You can multiply every single number in the table by 16 and then add it up, or shortcut, add them all up and multiply your total by 16. Okay, you'll get the same result. So add up your calories in your table, multiply by 16. After you multiply by 16, your total should be 12608. Okay, that should be your total. And again, they asked for the average. So the average is going to be my total, 12608, divided by, there's 5 different things he's buying, so divide by 5. So that's going to give us 2521 decimal 6, which is approximately 2,500. So 2,500 is your answer, which is D. Okay, bottom one is yours for homework. Top one at the next page, SAT number 3, also yours for homework. And let's look at 23. Those last two problems I gave you should be super quick. They're like 10-second problems. All right. Number 23. The grams of precious metal in recycled catalytic converters were measured for a variety of automobiles. Data is presented in the table below. If the lowest data point 1 and the highest data point 17 are removed from the set, which of the following quantities would change the most? So we're getting rid of 1 and 17, both ends. So let's just go through your answers here. Mode. Is the mode going to change? Was 1 or 17 the mode to begin with? No, so your mode's not going to change. So get rid of A. Mean. Well, your mean is going to change if you remove numbers. So leave B in the mix for now because we know it's going to change. Range. Your range is dependent upon your high and low. We just took out our high and low. So your range will change. So leave C in the mix. D, median. You took out 1 from each end. Is your middle going to change? No. get rid of median. Okay, so you're down to a 50-50 shot. Now let's talk about this problem. All right, there's two different types of data they can give you. They can give you data that's relatively spread out, or they can give you what's called clustered data. If they give you clustered data, it will be obviously clustered. You'll have like a whole bunch of 1, 2s, and 3s, and then a 17. Okay, that's called clustered data. You got everything on one end and like one thing on the other. Do we have that situation here? No, we don't have a bunch of 1, 2s, and 3s and then a 17. Again, they'll make it really obvious if you have clustered data. So we do not have clustered data. We have data that's relatively spread out between this 1 and 17. If you have data that's relatively spread out, then your mean is incredibly stable. By taking out a couple numbers, our mean is not going to move very much at all. Okay? So our mean is not going to change very much. The one that's going to change more is going to be your range. And again, I've seen this question used multiple times. It's always been with data that is spread out, so that means your range is always going to be the one that's going to change the most. Okay? Any questions on that? If you ever see clustered data, you need to calculate your mean and your range before they take out the numbers and your mean and your range after and see who changes more. Okay, but again, I've never seen it with clustered data before. All right, SAT number 33. If A is the mean and B is the median of 9 consecutive integers, what is the value of A minus B, the absolute value of A minus B? I don't want to do that conceptually. Let's do this with numbers. 9 consecutive numbers. So pick a number and we're counting up from there. 2. We're on a roll. We're starting with 2 and we're counting up. 2, 3, 4, 5, 6, 7, 8, 9, I think 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Okay, there's 9 consecutive integers. A is the mean. And B is the median. All right, so find your mean. Add them all up and divide by 9. And your median is your middle. Knock 4 off of each end. It's going to be 6. God, it's like a herd of elephants. What do you get? What do you get? What do you get? So you get 6, right? So you get 6 for the mean. Yeah. And then absolute value of A minus B, that is going to be 6 minus 6 is going to be 0. Okay? All right, your mean and your median will always be the same if you have an odd number of consecutive integers. Just FYI. But you don't have to remember that. They're always going to give you problems like this. They're not going to give you like 51 consecutive integers or anything stupid. They're going to give you a number where you can actually write it out and calculate it. All right, ACT 41. Set A and set B each consist of 5 distinct numbers. What do we mean by distinct? What does that mean? They're different. We don't have any repeaters. There's no repeaters in these sets. The two sets contain identical numbers, so the two sets are the same, with the exception of the number with the least value in each set. So the lowest number is different, otherwise the two sets are the same. The number with the least value in set B is greater than the number with least value in set A. The value of which of the following measures must be greater for set B than for set A? Again, why are we doing this conceptually? Let's do this with numbers. Okay, we know set B starts higher, so give me a starting value for set B. Our favorite number? Yeah, let's go with it. Okay. So 2, and let's just count up from there, just to make our lives easy. We could pick anything we want. We could go like 2, 8, 312, whatever. But again, let's make it easy. Set A has to start lower, so let's start at 8, 1. But then the rest of the numbers have to be the same as set B. The only one that's different is the first number. So this is going to have to be 3, 4, 5, and 6. And then they're asking us about the mean, the median, and the mode. So let's figure those out. What are the mean, the median, and the mode for each one? Well, your median is going to be 4. Your mode doesn't exist. There's no repeaters. What's your means? I don't know what your means are because those are not the numbers I chose. 3.8 and 4. Okay. So 3.8 and 4. So the value of which of the following must be greater for B than for A? So which one is bigger for B? Yeah, your mean. Only your mean. So mean only, which is A. All right. That was the last of the normal MMM problems. We're going to move on to the funky ones. Okay. All right, guys. So funky MMM problems. These have a 6-step process. This is an old Sylvan trick. I love it. It's a weird process. It's a lengthy process. It's a pain in the butt. But the good news is it's a cookie cutter. It works for every single odd, like these weird MMM problems that come up. Okay. So up at the top, we're going to go through the steps, but we're going to do it with an example, because if you don't do it with an example, it makes no sense. So up at the top of the page is your example. So it's SAT question example. A student has averaged a score of 75 on 4 quizzes this semester. In order to raise her average to an 80, what is the minimum score she can get on the 5th quiz? Okay. So for step 1, what we want to do is establish categories, and there will always be 3 categories on these problems. And then we want to say how the categories relate to each other. Okay. So in order to figure out what your categories are supposed to be, you want to ask yourself one of 2 questions. You either want to ask yourself, what is the person in the problem physically doing? Or how is your data broken up? One of those 2 will apply to your problem. In this problem, let's ask ourselves, what is the person in the problem physically doing? What is my student physically doing in this problem? What action is going on? Yeah, I heard somebody whisper it. What did you say? Taking a test. She's taking tests. So my number of quizzes is going to be my categories. What is she doing? She's taking quizzes. Therefore, my quizzes are my categories. Okay? All right. So what do I have for quizzes? I have 4 quizzes. Okay, so she's got 4 quizzes. She's taking 1 more. And I have data on 5 quizzes. So those are my 3 categories in this problem. Okay. Now I have to look at how my categories are related to each other. Now this is always going to be a basic addition or subtraction problem. Okay. So how are 4, 1, and 5 related? Yeah, it's just a basic addition, right? 4 plus 1 is 5. It literally is going to be something that simple every time. Okay. All right, that's step 1. We got our categories and we have our equation relating them. Step 2, this is a no-brainer. All you have to do on step 2 is write A, N, and T under each category. And that stands for average, number, and total.